If you consider example 2 on page 537 of the text, you'll find this here diagram. And in this short video, we will explain this diagram, or we will at least try to. Consider function f of x as follows. Take its linear factorization, which clearly reveals to us the roots of function f. Now, what exactly are we trying to do? We are trying to discover the splitting field for function f. Some would propose that this field here is the way to go, but we can clearly see that this field is no good because, based on the definition, it does not completely contain all the factors because it omits these two latter factors here. Similarly, this field here is also no good because it omits the first two factors in the expansion of function f. As is given to us in the text, we know that the splitting field that we are looking for is this one right here. And so now we can take in its diagram. At first glance, you'll notice that they're telling us that the degree of the splitting field is 4. That is per theorem 14. If we apply theorem 14 to the content that's given to us in this exercise, we have this statement where the latter two factors each have a value of 2, producing a product of 4, which is in agreement with the green material above. Also, what is the significance of the square root of 6? Well, consider corollary 18, and let's say we allow square root 2 to be alpha, square root 3 to be beta. Since those are algebraic, then the product must also be algebraic, hence the inclusion of square root 6 in this model. Lastly, just by way of demonstration, suppose you only wanted the splitting field for this part here in orange. Well, the diagram corresponding to that would be this component here. Similarly, the splitting field for this function would be on the right-hand side. And yes, the splitting field for this function here would be this center component. But as is, the splitting field for the desired function is the given field here.